Well, thank you for joining me on this exercise 3G. I'm going to be looking at question 8, part B. It says prove the following properties of conjugate complex numbers, and we've got Z1 plus Z2, the conjugate of that. We want to show that that equals the conjugate of Z1 and the conjugate of Z2. So let's say that Z1 be A plus BI, and let Z2 be C plus DI, where A, B, C, D are elements of the real numbers. And let's say that let's just leave it at that. So let's substitute. So we put A plus BI, and now we want Z2. Well, actually, let's set it out like this. Let's say the left-hand expression equals, and so Z1 plus Z2. Start with what the left-hand expression equals. Now we put the substitution in here. Z2 is C plus DI, and we want the conjugate of that. Well, let's get the real components together, A plus C, and let's put here B plus DI, the imaginary parts together, and we want the conjugate of that. So where there's a plus, our conjugate will have a minus. So that would be still A plus C minus B plus DI. Alright, so let's split this up into, now let's just go across to the right-hand expression. So let's start with the right-hand expression now. And what have we got? We've got the conjugate of Z and the conjugate of Z2, Z1 and Z2. So we want the conjugate of A plus BI and the conjugate of C plus DI. And so the conjugate where we've got a plus, we want a minus. So where we want a plus, we want a minus. So that would be A minus BI, and this would be C minus DI. So there's our conjugates. And if we group the real components together, we would have A plus C. And then if we group the imaginary components together, we would have B and D are both being subtracted I. And now you can see, therefore, the left-hand expression happens to be identical to the right-hand expression. So I hope this has helped. Until next time, stay happy.